Chapter 8.2 L'Hopital's Rule. When we were studying limits back in Chapter 2, we noticed that sometimes limits would be undefined and we had to use a little bit of algebra in order to evaluate the limit. So in the beginning of this, we're going to talk about something called indeterminate form, or when we get 0 over 0. We know that 0 divided by any number is simply just 0. And typically, 1 over 0 results in infinity because you're going to be approaching 0 on the x-axis and you end up getting very large very fast because the denominator is becoming very, very small. So if f of x equals g of x, which equals 0, which means the functions for all x will equal 0, when x equals a, then the limit as x approaches a of f of x divided by g of x cannot be found by direct substitution. This means that we simply can't just plug in the constant a or 5 or any number that it represents. When we substitute it this way, it produces a 0 over 0, which is a meaningless expression. This doesn't tell us anything. And this is known as indeterminate form. So a very smart man named L'Hopital came up with the rule then if f of x equals g of x equals 0 for some a, then the limit as x approaches a of f of x divided by g of x is equal to the limit as x approaches a of the derivative of f divided by the derivative of g at the point a. So now we're going to see that in practice. So example 1. The limit as x approaches 0 of the square root of 1 plus x minus 1 all divided by x. So if we work this out, we see that by just plugging 0 in using direct substitution, you get the square root of 1 plus 0 minus 1 all divided by 0. So this becomes the square root of 1 minus 1 over 0, which is 1 minus 1 over 0, which is 0 over 0. So this does not tell us anything about the limit. This is not useful. We need something that will be useful. So we're going to go ahead and use L'Hopital's rule. And the way I denote L'Hopital's rule is I write capital L apostrophe capital H. So if you ever see this, that means I'm using L'Hopital. So here we're going to get the limit as x approaches 0 of the square root of 1 plus x minus 1 divided by x becomes, using L'Hopital's, the limit as x approaches 0 of the derivative of the numerator divided by the derivative of the denominator. Be very careful not to get this confused with the quotient rule. We're not using the quotient rule here. We're not taking the actual derivative. We're using L'Hopital's rule. So the derivative of the numerator is going to be 1 over 2 square root of 1 plus x divided by 1. So this is the limit as x approaches 0 of 1 over 2 square root of 1 plus x. And then now we're going to use our direct substitution and just plug in 0. And you get 1 over 2 square root of 1 plus 0, which is going to be equal to 1/2. So this means that the limit as x approaches 0 of the original function is also 1/2. So now on your own, I want you to try to determine the limit as x approaches 3 of the square root of 6 plus x minus 3 all divided by x minus 3. Alright, let's see what we get. So if we just plug this in using direct substitution, we're going to get the square root of 6 plus 3 minus 3 over 3 minus 3, which is going to give me the square root of 9 minus 3 over 0, which is 0 over 0. Again, this does not tell me anything. This is no good. So what we're going to do now is we're going to use L'Hopital's. So we're using L'Hopital's rule. And we get that this is the limit as x approaches 3. And the derivative of the numerator is going to be 1 over 2 square root 6 plus x The derivative of 3 is 0, all divided by 1. So this is the limit as x approaches 3 of 1 over 2 square root 6 plus x. So now by plugging in 3, we get 1 over 2 square root 6 plus 3, which is 1 over 2 square root of 9, which is going to be 1 over 6. So the limit as x approaches 3 of our original function is going to be 1 over 6.